In this video, we will learn how to use the fundamental principle of counting with permutations and combinations. If an operation can be performed in m ways, and the second operation can be performed in n ways, then the total number of ways to perform the sequence of two operations is equal to the product of m times n. That is the fundamental principle of counting. It helps us to deal with more than one event, I guess you can say, and we would like to find a combined number of ways for these sequence of events to happen. Here's our example. 3 research departments have 10, 6, and 9 members respectively. Each department is to select a delegate and an alternate to represent the department at a conference. In how many ways can this be done? I would like to point out something very important. We need to choose a delegate and an alternate. The roles of these two individuals will be different, and whoever is chosen first as a delegate versus whoever is chosen second as alternate makes a huge difference. Therefore, order matters, and therefore we're using permutations. I have 3 different operations to perform. I need to know number of ways to select 2 individuals, order matters, out of 10 in the first department, then 2 individuals out of 6 in the second department, and 2 individuals out of 9 in the third department. So there are 3 numbers of ways to do this, and then again I would the combined number of ways. Therefore I am finding these results, 10p2, 6p2, and 9p2, and I'm multiplying these outcomes according to the fundamental principle of counting. I find the product of those numbers of ways. As you may recall, the formula for computing permutation says 10p2 will be found by 10 factorial over the difference between 10 and 2 factorial, and similarly for other permutations here. Simplify denominators, please. And now we get to this point, and here's where I wanted to do this together with you as you are watching this video. If you want to use a calculator, you can, but this is not too hard to do without. 10 factorial and 8 factorial are pretty close, so I'm going to look at 10 factorial as 10 times 9 times 8 factorial, the rest of the natural numbers, and 8 factorial will reduce, leaving me with 90. 6 factorial means 6 times 5 times the rest of the numbers, which can be expressed as 4 factorial, and of course 4 factorials will be reduced again between the numerator and denominator, leaving me with 30. Finally, same approach, 9 factorial means 9 times 8 times 7 factorial, 7 factorials reduce, leaving me with 72. Please multiply these numbers, 90, 30, and 72, and you should get, when you're done, 194,400. It's hard to imagine, but there are 194,400 ways of getting this done. Selecting 2 individuals when order is important out of each department among the 3 departments. At this point, I would like to take a look at how to compute something like this using a calculator. Go to Math, Probability, choose second option. Type in your numbers, 10, P2, press times, and go through the same process again with the next 6P2 times, third time, 9P2. As you can see, the solution we got using a calculator is the same as the one we got before.